Welcome to this particular session wherein this is the third problem related to block friction, and this is a problem wherein there are two blocks been connected and the two blocks are interconnected by a flexible string, and there is no any supporting agency like a cable or neither an external force that has been connected to neither of the block, and this particular block needs to be kept under equilibrium position only by means of adjusting the angle theta, that is nothing but the inclination of the plane. So we'll read out the statement of the problem and then proceed to the solution. So the statement of the problem goes like this. It's a block A of weighing 1000 Newton. So weight of block A is 1000 Newton, and weight of block B is 500 Newton. So this is block B of weight 500 Newton, block A of weight 1000 Newton, connected by a flexible wire. So both are connected by a flexible wire. The coefficient of friction between block A and the plane is 0.5. That is block A and the plane. Here coefficient of friction is 0.5. That is mu at A is 0.5. That is what is the given statement means. While that between block B and the plane is 0.2. That is at this particular junction coefficient of friction is 0.2. That is mu at B is 0.2. So we need to determine the value of the inclination of the plane so that the system will be has an impending motion down the plane. So there is no possibility that the block A and B on its own will try to move in the upward direction, because you don't have any external agency so that the block A and B will move in the upward direction. So because of the gravitational attraction, and the tendency of this particular block is always to slide down the plane, so which indicates block A and block B will always have the tendency to move in the downward direction. So here, to start with the solution, we need to have a few rules and few protocol that we need to do. So first one is we need to draw free body diagram. Next one is we need to ensure that the self weight is always vertically downward, irrespective whatever may be the plane, self weight is always vertically downward. Then normal reaction will always make an inclination of 90 degrees. It will be perpendicular to the plane of contact. Then the last rule is nothing but frictional force will be always opposite to the movement of the body. If the movement of the body is downward, so frictional force will be upward. If the movement of the body is upward, so frictional force will be in the downward direction. So frictional force will be always opposite to the movement of the body. To begin with the solution, first we need to draw the free body diagram. To draw the free body diagram, we need to isolate the body, block B and block A. So this is nothing but after the isolation of the body, block A and block B. After isolation, we need to place the coordinate directions now. Now coordinate directions can be placed in two ways, either along horizontal direction x-axis or vertical direction y-axis, or along the inclined direction as x-axis, and perpendicular to that will be nothing but y-axis. The direction of this particular coordinate system will be all dependent upon what direction the given object will try to move. Now as it has been placed on the inclined plane, so obviously block A and block B will try to slide along the inclined plane. There is no possibility that the block will move along the horizontal direction. As it has been placed on the inclined plane, the object will try to slide down the inclined plane. For that reason, it is essential to mark the coordinate directions along the inclined plane. To mark the coordinate directions along the inclined plane, as this is the inclined plane, we will mark this particular as the inclined plane. Similarly here this as the inclined plane, and mark this as x-axis. Perpendicular to that you have one more axis which will be marked as y-axis. Instead of taking it along horizontal x-axis and vertical y-axis, it will be marked along the inclined x-axis and inclined y-axis. For the reason block A and block B will slide or move along the inclined plane. If the same block had to placed along the horizontal direction, then you are going to consider x and y axis will be the coordinate direction. Likewise, as you have marked x axis here, this direction shall also be called as x axis, and perpendicular to that will also be marked as y-axis. So these will be the coordinate directions that we need to consider for the solution. That is, when we apply equations of equilibrium, summation fx and fy will be these particular coordinate direction. Now next task is to see, that is, the first diagram is nothing but drawing the free body diagram. So you have marked the x-axis and y-axis. So we need to mark self-weight now. Now self-weight will always be in the vertically downward direction. If I mention vertically downward direction, means it will be parallel to the conventional y-axis. So I shall mark self-weight in the vertically downward direction like this. Similarly, self-weight of this particular block be in the vertically downward direction. Now what is the magnitude of this particular block? Now this particular block is named as A, and self-weight of block A is 1000 Newton. So mark this as 1000 Newton. Similarly, self-weight of this particular block, the name of this particular block is called as block B, and self-weight is 500 Newton. So mark this particular self-weight as 500 Newton. After noting down these particular directions, we need to note down what will be the inclination made by these particular weights now. Now to inclination made, if this is theta, if you mark the inclination here, this will also be theta, and perpendicular to that, this will be 90 minus theta, and this inclination shall be marked as theta. If I happen to mark it in a comfortable way, the inclination mentioned here will be theta. If you transfer the inclination here, this angle will also be mentioned as theta. Then what will be this angle now? As this is vertical, this angle will be 90 minus of theta, and the left out angle will be theta. Likewise, if this is the inclination that we are going to consider as theta, and parallelly if we shift it here, this angle shall also be theta, and this total angle is 90 degrees because it is perpendicular, it is vertical. So this will be 90 minus theta, and this will be theta. So that is what is the inclination made by the self-weight of the block. If we consider independently, the independent directions will be mark x-axis and y-axis. Mark x-axis and y-axis. 1000 Newton is a force downward. 1000 Newton is a force downward. And inclination subtended here is theta. Likewise, mark x-axis and y-axis further here. Okay. If you mark x-axis and y-axis further, then 500 Newton force downward. This angle will be again inclination being marked as theta. Same. Only the change here is you don't have a block, you are marking only the force directions here. So this direction will be called as y-axis. This will be called as x-axis. After noting down this particular part, so self-weight will be always vertically downward direction. The next one is what? Normal reaction. That is, reaction will be offered by the plane of contact now. Now block B is in contact with the inclined plane. So with respect to the inclined plane, it is perpendicular to the plane of contact. That it is 90 degrees. Similarly, 90 degrees at this particular junction. If that has to be 90 degrees, so reaction will be perpendicular to the plane of contact here. Reaction will be perpendicular to the plane of contact here. Reaction will be perpendicular to the plane of contact in the upward direction. So this will be the reaction component. And similarly, here also reaction component will be marked in the upward direction. Why upward direction? Because self-weight is downward. So reaction will be opposite to the movement of the body. So it will be marked in the upward direction. So we shall name this particular reaction component. This reaction component I shall name it as N1. If I name here as N1, this reaction shall be named as N2. So same forces we'll try to note down here. As N1 is parallel to y direction, it will be shown in the upward direction as N1. And this will be shown here further as N2. So this will be the reaction force as N2. The normal reaction component is also over now. Now coming on to the frictional force direction. Now frictional force direction is opposite to the moment of the body. By observing this particular block B and block A, there is no any external force or been applied along the upward direction. So moment of block A and block B along the upward direction is totally ruled out. So as a resultant, block A and block B will necessarily move in the downward direction. If it moves in the downward direction, so frictional force will be opposite to the moment of the body. As block A and B moves downward, frictional force will be in the upward direction, and this frictional force will be called as F of F2. Likewise, the frictional force here shall be named as F of F1. Now as it is a force moving upward, I shall show it here. this will be a frictional force moving upward, which will be named as F of F2. Likewise, here it will be shown as F of F1. So this will be the frictional force now. Now what is frictional force now? Frictional force will be always mu times of 1. So if it is F of F1, it will be called as mu times of N1. If it is F of F2, it will be mu times of N2. So mu times of N1 means mu here will be called as mu of A, and here it will be called as mu of B. Mu of A is 0.5, mu of B will be 0.2. So if I write down here, this will be 0.2 times of N2, and this value will be 0.5 times of N1, because mu of A is 0.5. So mu of A will be 0.5 times of N1. So that will be the value of frictional force, 0.5 times of N1. So this is nothing but the frictional force and normal reaction and self-weight. Now coming on to the interconnected cable now. Now what direction this interconnected cable will move now? Direction forces. So this is purely an assumption. Now as this particular block A moves downward, so obviously it will transfer the whole force to the tension, that is to the cable now. When it transfers the whole force to the cable force will be shown in the downward direction here as T. If this has been shown in the downward direction as T, resultant opposite will be in the upward direction. So here also we will show T upward, and here T will be shown in the downward direction. So here T will be shown upward, and here T will be shown in the downward direction. This T is pertaining to block A, whereas this particular T is pertaining to block B. So same directions we are going to incorporate in the force diagram here. This is pertaining to block B, and this will be pertaining to block A. This is frictional force. This is T force now. So we shall start with the solution by applying the equations of equilibrium. We need to apply equations of equilibrium to ensure that the block does not move in the downward direction. So we shall apply first equations of equilibrium for block A, which is of 1000 Newton. Block A of weight 1000 Newton. Block A of weight 1000 Newton. So which is nothing but this particular diagram we are going to refer. So take summation Fy is equal to 0. If you take summation Fy is equal to 0, 1000 Newton force will be resolved along vertical direction and horizontal direction. If this is theta, so this particular inclination will be sine of theta, and here inclination will be cos of theta. And the self-weight of this particular block is 1000. Now if I resolve this particular force component parallel to y direction, which indicates minus 1000 cos of theta, because it is a force downward, so minus, plus of n1 because force is upward, plus of n1, so that is equal to 0. So as a resultant, n1 will be 1000 cos of theta. So name this as equation number 1. So keeping this equation as it is, we'll try to find out the frictional force. Frictional force value will be mu A times of n1. What is frictional force here? 0.5 times of n1, which will be 0.5 times of n1, which will be 0.5 into 1000 cos of theta. 0.5 into 1000 will come out to 500 cos of theta. So this is equation number 2, what we call it as frictional force F of F1. Likewise, take summation Fx is equal to 0. If you take summation Fx is equal to 0, referring to this particular diagram, this has an x component force, that is along the x direction. Here this is x direction, so parallel to x direction is this force, which will be minus 1000 sine of theta. Summation Fx will be minus 1000 sine of theta, because it is downward, so minus 1000 sine of theta. Then likewise t is also towards left hand side, minus of t. Then you have a frictional force upward. Why upward? Because block moves downward, so frictional force will be shown in the upward direction. So plus of F of F1. So that is equal to 0. So that is equal to 0. So t, when you take this on right hand side, can be written as t is equal to F of F1 value is already known, which is 500 cos of theta minus 1000 sine of theta. 1000 sine of theta. This is equation number 3. So this particular t value, we keep it as it is now. Now this completes all the solution pertaining to block A, which is of 1000 Newton. Now same solution, same procedure we need to adopt even for block B. When we adopt for block B, so if I draw the diagram of block B again, so block B force diagram, self weight is 500 Newton downward and inclination here is theta. T is shown in the upward direction because it's a resisting force for the block A, and frictional force is also shown in the upward direction, which is shown as F of F2 here, F of F2, which is shown in the upward direction. And the value of F of F2 is coefficient of friction between block A, block B and the plane is 0.2. For that reason, it will be written as 0.2 times of N2. So showing that particular force as 0.2 times of N2, N2 is been shown here. So this is nothing but the normal reaction now. Now we shall start with a solution for this particular block by considering summation Fi is equal to 0. If you consider summation Fi is equal to 0, N2 is shown upward, so positive. N2 is shown upward, so positive. This 500 Newton force again will be resolved along vertical direction and horizontal direction. So when you resolve this, it will have an horizontal component here as sine of theta and vertical component as cos of theta. As it is, magnitude of the force is 500, so this will be 500 sine theta and this force will be 500 cos of theta. So as N2 is upward, positive, then here force is downward, so minus 500 cos of theta, that is equal to 0. So N2 will be equals to 500 cos of theta. So equation number 4. After that, we are going to find out frictional force here. Frictional force will be again mu times of N2, which is nothing but mu times of B. Now mu times of B is 0.2. So which is 0.2 times of N2, which will be 0.2 times of 500 cos of theta, which will come out to 100 cos of theta. 100 cos of theta, because 0.2 into 500, 0.2 into 500 will come out to 100 cos of theta. So this is what is the value of the frictional force F of F2. So this is the frictional force magnitude, which is the magnitude of this force. Next we need to consider summation Fx is equal to 0. If we consider summation Fx is equal to 0, refer to this particular diagram now. Now T is upward, so plus of T. Then frictional force is also upward, so plus of F of F2. Then 500 sine theta is downward, so minus 500 sine of theta downward, so that is equal to 0. So T, here T was considered as negative, here T was considered as negative, T was considered as negative because it was downward. Now here T is upward, so it will be considered as positive. For that reason, T here was considered as positive. Now T value will be rewritten as 500, this is 500 sine of theta. When you take it on the right hand side, it will be positive because it is 500 sine theta. When you take it on the right hand side, it will be positive 500 sine theta minus F of F2, which will be 500 sine of theta. F of F2 value is minus 100 cos of theta. So this is what is the value of T. This equation we shall name it as 5 and this equation we shall name it as 6 now. Now to find out this, you can equate equation 4 and 6. 4 and 6. If you equate 4 and 6, T here is on left hand side. In equation 4 also, T is on left hand side. So equation 4 value is 500 cos of theta minus 1000 sine of theta. So we shall write it here. 500 cos of theta minus 1000 sine of theta. Here 500 cos of theta minus 1000 sine of theta, which is equal to this is equation 4 now. Now equation 6 will be here now. 500 sine of theta minus 100 cos of theta. So if you reframe this equation by equating all the like terms here, this is 1000 sin theta, 500 sin theta. Take 1000 on the right hand side. This will be 1500 sin of theta, because 1000 will become plus 1000 plus 500, 1500 sin theta. Then 500 cos theta on the left hand side. On the right hand side it is 100 cos theta. So it will be 600 cos of theta, because 500 plus 100 will come out to 600 cos of theta. So reframing this equation, sin of theta divided by cos of theta is equal to sin 100 theta divided by cos theta. This will come in the denominator here, which will be equal to 600 divided by 1500. So tan of theta will be equals to 600 divided by 1500, which will come out to 2 by 5. So theta will be equals to tan inverse of 2 divided by 5, and theta will be equals to shift tan inverse, which will be 21.8 degrees. So this is how we are supposed to find out the inclination of the block. So if I substitute the value of 21.8 here, so t value will come out to substitute theta in t equation. So if I substitute theta in t equation, t will come out to 500 sin of 21.8 minus 100 cos of 21.8. So which will come out to 92.84 Newton. So this is how we are supposed to find out the inclination of the block. So as been mentioned in the statement of the problem, we are supposed to find out the value of the inclination theta, and the inclination theta is been calculated as 21.8 degrees. That is what is the unknown value that we have calculated here. So this is how we are supposed to solve when a block is been placed on an inclined plane and been connected by an string. Thank you. Have a nice day.